So we are founders of Prattle. Obviously, as the intro explained, we're a text analytics company, and really we began to really doing what we do to solve a very specific problem. We set out to analyze the content of complex, nuanced central bank communications. And I ended up having to develop a methodology that is applicable to a wide variety of other things. So with that, I'm going to sort of let Bill take over for a little while and fill you in on a lot of things.
How's everybody doing?
Awesome.
So I'm Bill McMillian. I'm the CTO of Prattle. So Evan, it's funny. He always jokes when he got a PhD to become a salesman. But his role in the company is really much more of sort of big picture. I'm the person left to sort of pick up the nuts and bolts to make computers do tricks. My personal experience before starting this company was actually as a sort of corporate data scientist. I worked for Monsanto, Express Scripts, things like that. What I found in this space, and I think this is a real common experience, is sort of the most sort of fully fleshed out solutions in the data science space with statistics. And I'm kind of being holistic about that and saying they're all sort of part of a thing that does data processing in a way. They tend to be very deep in the tech stack. They're a very varied kind of application. When I say deep, I mean there's a lot of information flowing into a system. Data science applications are sort of dealing with that information flow in some way. But then actual bigger sort of decisions about where we're going to expend resources, how we're going to do what we do, that happens at a much higher level organizationally, right? The data science, the statistics, it's really being used functionally just to sort of filter out a bunch of junk, and then you decide from this subset, okay, we need to do something in this space. So you see applications, the most common ones are really workaday, right? There's server log monitoring. It's looking to make sure that systems aren't breaking down. I can think of a couple of great government examples. So patent and trademarks. You go online or fax in a document saying this is my application. If you actually look at how the work is done in that space, they actually have a sort of regular topic analysis system that goes through and classifies that before anybody actually looks at it. SEC filings, the other sort of thing in this space too I see a lot of is bot-written news. So it's the work that nobody really wants to do on a regular basis, but then when you actually have to make decisions, that usually gets left behind in terms of the apparatus of statistical decision making. That's what I just said. There we go. So not used to actually make decisions. When you get to the point at which you're making some kind of strategic decision about resources, like I said, you're no longer using the apparatus of the sort of formal decision-making system. Okay. The history of statistics, of machine learning, of all this stuff is really 100% as an idea of, okay, we need a formal way to go through a process where we're going to choose what to do. So you look at the history of a lot of statistics, it actually comes out of beer making. So student's T, sort of this fundamental distribution that's used in statistics, it was literally made by this guy, whose pseudonym was Student, who's actually a quality assurance person at Guinness. And he wanted to figure out how do we test the quality of beer without drinking it all. Sort of counterproductive, right? And so he took the sort of typical apparatus that was at the time in terms of statistical decision making, which involved these very large samples. You wanted to sample things thousands of times. And said, well, is there a way we can do this where we're only taking 20, 30 samples of beer instead of all of the beer? What's happened, though, in sort of the evolution of how statistics is used to make decisions is that the real sort of grunt work in terms of using these kind of formal decision-making systems happens at a really low level in the process. As you rise up the organization, as you make bigger decisions, you leave behind that apparatus, right? And so this is something, for those of us that have worked in the corporate setting doing this kind of work, you'll see that there's these very discrete teams, right? You have data scientists or statisticians. They're sort of in one camp doing their thing. You have IT and big IT, often a totally different space, maybe not even the same building. You don't really talk to them. You're not allowed to talk to them. If you try to talk to them, somebody slaps your hand and says, don't do that. And then sort of the third element of, well, who is it this is actually impacting? Who is ultimately making decisions? Who knows something about this problem, right? That is being in sales. It may be in some weird spot in the organization that you never actually interact with. You don't have that kind of thing that sort of allows for even a basic kind of fundamental building of a team that says, okay, this is how we make decisions in a formal way. The end result, and this is something you'll see very frequently, right, is much of the work that's done by data scientists and statisticians has a very ad hoc and kind of almost sort of toy feel. It's like, look at this very cool graph I made. It's very informative, isn't it? Isn't it great? It's not actually used in the way that a lot of folks would hope, which is, okay, this is going to make a decision, right? This is going to be something where we don't just look at the curve of the line and say, that's pretty cool. We actually use those numbers in consequential ways to decide where resources get spent. Yeah. So we're going to talk about two examples. We're going to talk about, it's ironic, rapid GD forecasting, or nowcasting, it's sometimes called. It was actually a big subject of the last talk just before in this room. Thinking about how sort of refactoring ideas about how we consider the well-being of people internationally. And we're going to talk about, then again, our quantitative central banking data and how that process got built up. To not only just having the product, but then how that sort of flows into the bigger picture of how we try to do what we do. So the problem with GDP or a lot of these other measures of sort of the health of the economy generally, and this is a big thing of people get really hung up on this, is the strategy that people have is like, let's make a bunch of surveys, right? Let's survey business owners, let's survey people that are looking for jobs, let's put people at ports that are sort of taking a census of things coming in out of that port. It's all way, way behind the actual activity of that thing, right? So I didn't put up the equation for it. The basic idea is you're sort of looking at how people spend money, how people invest money, how governments do the same thing, and who's buying or selling things overseas. The way that this happens in practice is the Bureau of Economic Analysis, the Census Bureau, puts out these surveys. They put people in the field to actually record this information, and that information sort of trickles in to these different agencies, and they aggregate that up to a certain level, and then they say, well, this is what GDP is. It ends up that the GDP that they actually announce is sort of months after that point in time. So the official sort of final forecast for Q3 GDP won't be released till the 22nd? 22nd of December. So literally a whole quarter has passed since that number was relevant, right? In the meantime, as the information trickles in, there's sort of this ongoing revision process. Well, we have most of the information, so we take a guess. Well, then, a month later, they're going to take a different guess because different information will come in. You never really know what the underlying reality is. So one of the big changes in this space has been the evolution towards what's referred to as nowcasting. The idea of, well, let's build an econometric tool that allows for a more systematic introduction of this rolling information that comes in via these surveys. The major sort of difference between nowcasting and say what the government does is they essentially sort of break the structure of the national accounting. So literally the Bureau of Economic Analysis has a table. It has 4 major entries, 11 sub-entries. You can keep sort of going down this rabbit hole of entries. And they wait until they have enough information. They sort of write in the ledger, this is this number for this part of it, right? And then they add them all up and say, well, this is GDP. Nowcasting says, well, we just have a bunch of information that's rolling in. There's going to be some mapping between this information and what GDP or unemployment or any kind of figure is. We don't care about that structural sort of connection between what the tables look like. We just know that these influence the final numbers. Our work in this area very recently has been, well, let's take and sort of figure out, well, what's valuable in knowing the tables. I feel like as a statistician, as a data scientist, you're always at a disadvantage if you're throwing information away, regardless of the nature of that information. So there's a lot of information in those tables, right? This is literally structurally how the government is doing it. And so if you throw away the information where you're actually saying, well, the government's putting it in a table and adding these things together, you're no longer able to use that information in kind of a strategic way, a kind of way of sort of guiding the actual information flows coming into it. Our approach in this space has actually been sort of step 1 is, well, there's some good things about both approaches, sort of waiting for the information or having this kind of rolling informational approach. The big picture is effectively, where you know something, like the government has a table and they're filling in entries, use that information explicitly. Don't be afraid to take parts of sort of the bigger picture of the math that you're using and actually say, here's an entry, we can forecast this part here specifically, and then we know these things are added together in this way. So there's not necessarily a need to go and say, just say, well, we don't know the mapping. Well, we know the mapping. It's explicit. It's in this table. on the other part of it then is, well, there's certain things that we don't know as well, right? So how different parts of those entries into the table influence each other. So that's then where the sort of data science becomes radically valuable, because then we can say we don't really know anything about this, and we're going to use every sort of non-parametric trick in the book. We use every tool that we have at our disposal to go and say, all right, there is some mapping. It's important. We're going to forecast stuff, but we don't know anything more than that. Our adaptation in this space has been to take not only this structural approach at the bigger level and using data science techniques, but then we can still take advantage of the sort of rolling information, or alternately information that exists at a very sort of fine level, disaggregated quite a bit. So daily and weekly data on what's happening in labor markets, what's happening in ports. We can take that information and again adapt it to the specific kind of approach where we know there's going to be information flow, we know it's going to aggregate in a certain way. Ultimately, we'll end up in a table line item in a certain format. So from there, since we have this combination now where the spaces that we know data science works or is valuable, the spaces where we know something about the process at a higher level, we can now have both of those parts, right? We can incorporate the non-traditional data, but we also are then sort of speaking to the things that analysts most care about really directly, right? Which is like, well, what's happening in the job markets? What's that going to do to the accounting tables? Sort of the extra added value of this then too is, what you find in a lot of the sort of broken mapping systems is that you lose a lot of model accuracy. And it's sort of obvious, you're throwing away information. You're not going to retain the ability to speak to the sort of smaller parts, but in addition, because you've lost information, you're no longer going to be as finely accurate. Yeah, next slide. So, moving on, another big topic we're going to talk about here, and Evan's actually going to take this in just a minute, because really it's more his domain, which is part of our whole spiel here. Is talking about central bank analysis. Yeah, so we started off when Evan said this is a cool idea, we should do something. I started off looking at sort of what are the typical solutions in this space. What you find in sentiment analysis is a very kind of one of two things. You have a machine learning approach where you need huge, large amounts of volume of data to actually say something. So it's the typical solution of sort of like naive Bayes on Amazon reviews or something like that, right? We have many millions of documents you're coming through. In the case of central bank analysis, this is not something we can use, right? We're looking at a few thousand communications for a long history. On the flip side, you get something that's very common, which is like, well, let's have a dictionary of good words and bad words. Let's count up the good words, count up the bad words, subtract one from the other, that's sentiment. Now, in the case of central bank analysis, this is a much more challenging issue. And I'll let Evan describe the issues more specifically.
So, essentially, what Bill's laid out here is not just a methodology by which we analyze central banks, which I'll get to in a moment, but a methodology by which we have created an interplay between data scientists, system maintenance folks, and experts in the field. And this really, as I started out saying, came about for a very discrete purpose, right? We knew that a pure data science solution was never going to work for analyzing complex, nuanced central bank communications, right? These communications, the word modest and the word moderate might mean virtually the same thing to you and me in daily language. For a central banker, they're worlds apart. Modest is the 30th percentile. Moderate is the 75th percentile, right? Modest is, the economy's doing poorly. Moderate, pretty good, right? So how do we solve that problem? How do you actually approach that problem using text analytics tools? So let's trace this back. Some of you in the room are probably old enough to remember the briefcase watch. This was Fed watching back in the 1990s, right? So camera crews literally used to follow around Alan Greenspan on the day of an FOMC meeting and photograph his briefcase. If his briefcase was thick, the thought was rates were going to change. If it was thin, rates were not going to change. The logic behind this was pretty simple. If it was thick, he was reviewing data. If it was thin, it wasn't. You usually know that it's either rates are going to stay the same or they're going to change in one direction. They're not going to change the opposite direction. So never mind the fact that Janet Yellen would be carrying a computer, not actual physical papers. The odd piece about this is that actually not that much has changed in traditional Fed watching, right? Reporters still follow these folks around and try and prod them with questions and try and discern bits of information from now individual words or phrases, maybe a sentence. But what they're not doing is actually looking at the enormous amount of information that central banks now provide. Over the last 30 years, but specifically over the last 15 to 20, there has been an informational revolution coming out of central banks all over the world. They have become more transparent. That means there's all kinds of data coming out of that. When I say data, I don't mean quantitative data. I mean verbiage, I mean words. And in this context, words are data. So, with that, by the way, this is a real DC comic. It actually does exist, in case you're interested. So, how do you get at that data? How do you analyze those complex, nuanced communications? Well, you could have a group of experts, and I can tell you I spend a lot of time with those folks. Depending on your standards, I might be one of those folks. And every last one of them, us, will admit we are biased. We are human beings. We are not good at having perfect memory. We're not good at remembering that communication 15 years ago that was about a similar policy that actually institutionally is being recognized in the communication. We may miss that, right? We're very good at saying, oh, the news has been talking about the word patient. I better look for that. So, given that, and given the fact that we know simple text analysis dictionaries that Bill outlined, those happy and sad words, don't work. It's the modest moderate problem. How do you deal with this issue? How do you scale a system that actually analyzes complex, nuanced communications in real time? So, the answer is, as with everything, is the premise of our talk here. You have to combine expertise. You have to have experts talking to data scientists, talking to systems folks. You have to bring everyone together. These siloed teams don't work. So that allows experts to come in and say, here are the impartial metrics we know work. So for instance, in the case of central bank communications, we look for market response. Short, medium, and long-term market response across asset classes. It's complex to find it, but it's there. And then you also have to integrate the expertise to subjectively say, okay, here are the hundreds of documents we found that elicited canonical market response. Which ones of these you actually use canonical language, right? So, what this system ends up yielding is not just incredibly fast, a matter of seconds or less, but it actually yields a singular score based on the sentiment of a whole communication that is comprehensive. It's looked at the entire communication in reference to the entirety of all communications from that central bank. It's unbiased because your primary input here is scaling based on market response, and it's actually quantitative. You just turned that complex, nuanced communication into something that is numerical and actually can be put into a time series. It's backtestable, right? So of course, this yields things like the ability to eliminate post hoc hedging, right? So I spend a lot of my time, Bill jokes, Bill joked before, I got a PhD to go become a salesman, right? Well, I spend a lot of my time talking to folks at hedge funds who, they care an awful lot about making the right decision in real time. It means that they either make money or lose money. And so with central banks, unfortunately, the policy has traditionally been to just not trade on it, right? Or alternatively, they are stuck post hoc hedging. So they have some complex model with multiple signals in it, and they have to say, based on what some qualitative expert came to them with minutes later, hey, this is what we think is going on, use that how you will in your quantitative model. By having quant data in real time, you can actually just plug that into the model and trade based on that signal. So, Obviously, there are a whole bunch of ways you can backtest this based on established correlations, and it can be additive or be used to build a model in and of itself. You'll note, obviously, our data here, the Fed index actually correlates much better with bond market movements than, of course, what the Fed funds rate is doing, but it's been an extraordinary time period. So, the interesting thing we found about this data is that it's not unique to fixed income markets. And one of the things everybody hears central banks and says, oh, fixed income, okay. What we found is actually that the correlations to equity markets are significantly better than we anticipated. And this is true across industrial sectors. We find the one consistency that we do find is that large caps tend to correlate better than small caps because they hold more cash on their balance sheet. But we've found that really across asset classes, so not just fixed income, but equities and FX, central banks matter. This is a classic macro matters story. And we've been able to quantify that and actually been able to develop investable vehicles to demonstrate that and in fact make money off of it. This is a simple backtest we ran using our data as a momentum signal. So not surprisingly, data like this winds up also being a leading indicator. This is one of those graphs Bill referenced before that, maybe it does or doesn't make you let you make a decision. But what's interesting here is that we found that we've consistently, a week ahead of time, been able to predict where the next communication is going to lie in terms of sentiment. That means that, in fact, there is a signaling game going on that is quantifiable. And we've been able to pick that up because we're actually able to glean real sentiment from these complex, nuanced communications. So, circling this sort of whole talk into a nice little bow, where are the other applications of this methodology? This bringing together experts in both data science and the domain-specific fields can translate to a whole variety of things. So in the text analysis world, that means analyzing other financially important texts, things like shareholder documents, earnings calls, regulatory documents, so SEC, FDIC, EPA, all of these things involve teams of lawyers who actually don't have the time or energy to do this and are frankly biased in and of themselves, same expert problem. Well, if you can plow through those documents in a comprehensive, unbiased way in real time, you just solve the problem. I don't have a belief that a whole lot of lawyers are going to be able to code that on their own. Just a guess. So this is sort of where our plea is that people like yourselves in the data science world actually work with substantive experts. So, takeaways here. Decentralize your teams. Don't silo together 15 computer scientists who never talk to a substantive expert in the field. It's not going to work. Create models that actually fit the application. Don't try to pull in models from other places. And allow data science to be a tool for not just guidance, but actually action. So that, I guess we have a few minutes for questions.
Are you concerned that by you measuring the sentiment of, for example, the Fed, that the Fed would then take notice of that and then change the way that they are speaking in order to kind of elude what you're trying to do?
It's a great question. So for those of you who couldn't hear it, the question is, are we worried that we will in some way alter communication by analyzing communication? No, I'm not worried about it. In large part because if in fact we're doing that, it means that we've got enough traction, enough people that are doing this that we've already kind of won. But no, the truth is we talk to central bankers every day. It's part of what we do. And by and large, the people we talk to not only like what we do, but have asked us to help them fine-tune communications so that they are getting the market responses they want. We have to be a little careful about working both sides of the coin there. You know, it is not a problem. These are people who want to be clear and precise in their communication, and when they want to be opaque, they know how to be opaque. And so I don't foresee that being a problem. The flip side is you talk to an investor relations department of a corporation that's running an earnings call, they might have different incentives. And that is a problem that needs to be dealt with. I don't have a clean answer for you right now. Yeah.
See, regarding the survey stuff, you guys see like bias different traditional type of surveys?
Feel that way?
So there's a couple of ways I think of thinking about the bias in this. You know, one from the sort of nowcasting, sort of the methodology of that versus the traditional NIPA, you know, count up line items. You know, and Evan could probably speak to this a little bit too. It's like there seems to be a downward bias in the results on average of those models, and I'm not sure exactly sort of econometrically why that's true. In you know the traditionally in terms of just sort of mean square error tests, a lot of the sort of the alternate approach refers to bridging equations, where you use ARIMA models and things like that to forecast individual elements and then aggregate that up as the government would do it anyways. Those tend to be a little bit more accurate, but they're also not as exciting because you're kind of just waiting for confirmation or not. The other sort of part of bias that me and Evan were talking about, thinking about some of these issues as we build in alternate data sources is, effectively sort of the common approach of, have 1,000 people, 1 million people, whatever, with their phones doing something somewhere to give you information, or whether it's devices embedded in some wall in a New York subway or something like that. Those are all effectively convenience samples, right? You really don't know, like, what's the process that's driving the information that's coming in through that device. You can sort of mentally create one and try to sort of use that to influence the numbers in some kind of a structural sort of way. But at the end of the day, it's a convenience sample. You don't really quite know. And so that's actually a harder problem to speak to in some ways. So you almost have to have a meta sort of set of reasoning about like how you use those kind of convenience devices like that in order to aggregate it to a higher level. Some of them, I think, are, some of the data is fairly straightforward. So one thing we've been working on is using satellite photography. You can kind of just photograph every parking lot, right? That's not as big an issue because you sort of have the population, or at least close enough that you can sort of, wink at it and say, yeah, you're the population, that's fine. With some of the other methods that are out there, it's a lot more challenging, I feel like, to be able to move beyond sort of a general, this is a statement about a sort of convenience sample, to using this in the math that you use for a structural model. People are doing really interesting work, but I don't really know. I haven't seen anybody work that math all the way through up to the point of here's a point estimate.
When you're talking about communication, you're talking strictly written communication. Do you use any speech?
Yeah, so the question is about whether we look at speech as well as written communication. For central bankers, so basically everything they speak as far as formal communications. So these are speeches. So when we talk about central banks, we talk about speeches, press releases, meeting minutes, if there's testimony before the relevant legislative body. So we cover 20 central banks around the world. We also have a separate engine built to do basically the same thing for interviews, but interviews are tricky because they're leading questions, right? So it's sort of a different, it has to be a it has to be a siloed system from our normal system, just because it has to be dealt with slightly differently. But we functionally look at everything, with the caveat that, of course, we can't cover the things that are off the record. Other questions? Yeah.
Have you had any hedge fund clients that use computerized trading methods that speak index?
Yes. The question is whether we have clients who use the computerized trading methods based on this. And the answer is yes, in various forms.
What has their experience been?
So like
a lot of the written data has been usually after the speeches. Right? So there was
Yeah, so what's interesting is it's not just about people who are actually using our data for trading. because to be honest, hedge funds are not exactly the most transparent places in the world. They don't often tell you exactly what they're doing with your data, unfortunately, no matter how many times you ask. No, we do know that certain funds have built models around our data. We do know that others are integrating the data into existing models. One consistency is that nobody trades commodities based on our data. That's interesting, but not surprising. All the relevant correlations we found in our back testing, others have found in their back testing, is that really the only commodity that matters with regard to our data is gold. All the other movements are just currency movements. The flip side of that is relative value trading is popular, right? Using the fact that we cover 20 central banks around the world means that people can look at a single screen and say, oh, this is what's going on in the US and Canada and Turkey and Taiwan and a whole bunch of other places all at once, and say, this is where I need to concentrate my energy. And that allows for not just FX trading, but relative value trades as well. So I don't know if that answers your question or just kind of muddies the water. Yeah.
I was curious if you could speak to how your central bank models might differ from one country to another.
So the short answer is we try not to have them differ too much. However, we scale all data on each central bank completely separately, right? So they're normalized to the same scale, but they have to be scaled separately, right? The way a Russian central banker communicates is going to look pretty different than the way somebody from the Bank of England does, right? One of the tricky things we have had to deal with is frequency of communication. So Russia and India release a ton of communications. On the flip side, Australia doesn't release very many at all. So we, of course, have to deal with the question of, does that mean each communication is more salient? Functionally, it has to be. So, yeah.
For the SEC filings from companies, what type of analysis do you
Want to fill that one? Sure.
So the question for those who couldn't hear was, what kind of work do we do with SEC filings? SEC filings are sort of an interesting beast because they are themselves kind of semi-automated in how they're produced. But what you actually get sort of from the government websites is not that clean necessarily. There's a lot of challenges. So there's sort of two parts of it, right? One is sort of what's the work we have to do in terms of natural language processing or document processing, and then there's what do we do with the information we get out of it, right? In terms of the first one, that's been sort of an interesting challenge because you can't rely on a lot of sort of the normal tools of thinking about, paragraph separation or just looking at sort of documents as a whole. You have to sort of find structural ways in like the way the document's actually written to extract sort of segments. The other non-trivial part of this actually is a lot of the information in tables, which is a whole sort of other issue I won't sort of touch on here. The second part of it then is what do we get out of those sections? Because each section in the SEC filings corresponds to a fairly sort of specific set of information you'd want to extract from it. And because of the nature of the language and because it is so formalized, some of the stuff that we'd like to do with, say, sentiment analysis can be a little bit more challenging, especially because the sections tend to be short and refer to a very specific kind of an idea. And so sort of the core technology of the central bank stuff, for example, is not greatly applicable in those spaces. Functionally, what we do is, in a lot of those cases, do one of two things. We take and we look at some kind of metric of extracting numeric information, so some kind of name-entity extraction, or alternately something a little more sort of exotic, where we take and we sort of look at different centrality measures across sort of chunks of text, like looking at sort of this sentence probably contains the information that's most relevant because it's sort of the most natural kind of sentence within this chunk of text. We extract that out, and then you can do lots of things from there, whether it's some kind of automated information extraction or you highlight it for an analyst to say, okay, what's actually here. The idea being eventually that we can get to a point where we can take all of the information that could potentially be consumed from that document and have that sort of machine readable in a variety of ways and not just sort of embedded in the text itself. Questions?
So maybe 20 years ago, sort of the analytic pendulum was sort of more along the AI.
components of a communicating entity and balance conflicting sub-sentiments.
Yeah, so the question is sort of along the lines of,
Is that what you're doing now different, or could it be natural?
the question, so the start of the question was, well, this is sort of how people would do this in a qualitative sense. You have a panel of experts, you figure out like what's embedded in that document or what could potentially be there. How do we interpret? Right, and in a sense, what we do is take that. The question is, do we do something different than that, where it's like we just computerize the set of rules? Is that yeah? The short answer is mostly yes. We do something different, but what we're trying to do, and we do in a lot of applications, is we talk to those exact experts. In fact, we talk to ex-central bankers, you know, and we say, like, how did you try to do these things? How did you try to say them? What was actually implied in this sort of message? We take those rules of understanding they use, and we use those explicitly then in the math in some way or the other. So it varies by application to some degree, right? But in the central banking context, you know, we know that they're trying to signal this is where we think markets are going, this is where we want them to go. We know explicitly that because we asked them, this is what they're trying to accomplish. And we take and we embed that directly in the sort of functional parts of the algorithm. So it's not just necessarily a filtering kind of a thing, it's something that structurally can adjust the numbers we actually see one way or the other, dependent upon how we actually perceive the application, you know, as it exists.
Think of it as a supervised, unsupervised approach. So, I think we're out of time.
Yeah, we're all out of time. You can, if you have more questions for the speakers, they'll be at the back of the room after the session. We're going to prepare for the next speaker now.
Thank you all.
Thank you, folks.